Hey, welcome back. I fixed that stray hair that was bugging me. So now we're going to move on to talk about how experiments establish temporal precedents and how they also establish internal validity. All right, let's go. So here it's pretty straightforward. The reason that experiments establish temporal precedents is because our independent variable, our cause in the cause-effect relationship, precedes the effect. So for example, in the Oppenheimer and Mueller note-taking study, our cause, the manner in which you choose to take notes, will precede the effect. Our dependent variable, how well you remember important concepts and can utilize deeper thinking strategies. And then finally, a good, well-designed experiment should establish internal validity. So we talked about the different types of validity with correlations. And we talked about a few different aspects of validity that are more important for correlational studies. For experiments, internal validity is absolutely critical. Internal validity is all about trying to establish that cause-effect relationship and trying to make sure as much as possible that there aren't other factors that dampen it. So we're going to talk about a couple of different ways that variables can basically become confounded, or different ways that we can weaken that cause-effect relationship. And we're largely going to be looking at two in particular. We're going to have what are called design confounds versus selection confounds. So I want you to imagine in, let's say, some alternate universe where Van Cleef and colleagues were performing their study, and they ended up putting in the medium bowl pasta that was not very good. And then in a larger bowl, so let's say in the medium bowl, they had like something like penne with vodka sauce or something like that. I like vodka sauce, but I have also found that for a lot of people, vodka sauce is a very acquired taste. It has a little bit of a tang that not everybody likes. Let's say in the larger bowl, we had something like fettuccine Alfredo or something. A lot of people really tend to like fettuccine Alfredo. So we have a medium bowl with a less appetizing pasta, and we have a larger bowl with a more appetizing pasta. Now, in this case, if we see that more people take from the large bowl than from the medium bowl, can we say it's because of the size of the serving bowl? We can't here. Here, it could be the bowl size, but we haven't ruled out the fact that people took more from the large bowl because the pasta in the large bowl was better. So we can't separate out those effects. This is what is called a design confound. There is some aspect with respect to the design and the way that the experiment was designed that makes it very, very difficult to tease apart what caused the effect in the behavior. Was it the portion bowl size, or was it how delicious the pasta was? We can't tease those apart, and because we can't tease those apart, there's no way of knowing. Better here to have the same type of pasta in each bowl. That way you know if they took more from this bowl, it was specifically because the bowl is large. That's the only thing that differs between the two. So we'll talk some more about these design confounds and also what are known as selection effects and how those can cause problems as well. So what are design confounds? Design confounds are confounds that basically introduce a systematic variability in your data. So systematic means that, for example, if the pasta in the large bowl is always better, that introduces a variability where people are probably going to take more from the large bowl than from the small bowl or the smaller bowl. So it's very systematic. That variability doesn't change across conditions. It specifically is systematic, and it's only for the large bowl condition in particular. Now, on the other hand, we can have what's called unsystematic variability. This is where we get some differences, but it's done in a really kind of random sort of way. It's not specific to a given condition or a given group. So for example, experimenters might treat participants differently. So some experimenters, they oftentimes with a lot of experiments, they're often run by multiple experimenters. When I was working in a lab in graduate school for a lot of the big studies, there would be multiple people, myself included, other graduate students and undergrads who were collecting data. And so because the graduate students had a little bit more experience, they probably treated participants a little bit differently than the undergrads did, who were probably a little bit less experienced. Now, here's the thing. Now, that does introduce variability, but it's not specific to a particular group or experimental condition. And you want to try as much as possible to reduce that variability as well, but by and large, systematic variability creates design confounds, and design confounds mean that you can't get that cause-effect relationship because you can't tease apart those confounding variables. So let's move on to talking about selection effects. So selection effects typically occur when there are differences between your experimental groups. So your book talks a little bit about a study by Lovas and colleagues, and it was done to look at different types of treatments for children with autism spectrum disorder. And so here's where it gets kind of tricky. And here's an example of how you should not do a study. So with Lovas, they were interested in trying a new intensive treatment. It was more involved. People would have to travel more often to the center to get that intervention. And so one thing that I will mention is that the participants in this study, like the parents and their children from this study, came from wide-ranging areas. So some people lived really close to the facility. They had more money. They had more means to do that travel. Now compare that to parents that are a little bit farther out. Parents that are maybe a couple of cities over. They don't have the time to make that commute. They may not have the resources to make that commute. And so here's what's kind of interesting. Now, if I were introducing a treatment like this, I'd want to make sure that my two groups, my group that's getting the same old treatment and my group that's getting the new experimental treatment, I want to make sure that they're as same as possible. One of the things that you can do is what is called random assignment. You randomly assign people to the different experimental conditions. And that way, if you have you should not have differences between your groups when you do this right, when you randomly select people and you've got enough people in each group. Well, Lovas didn't do that. Lovas tried. They tried as much as possible to randomly assign people to these conditions, but here's what ended up happening as a result. The people who were selected for intensive treatment that lived far out and didn't have the resources to commute very often were like, we can't do that. Can you put us in the other group? And then you had other parents that were starting to hear about this treatment, and they were basically calling up and saying, I want my child to be in this group. Please put them in that group. So you've created a selection problem. By and large, the group that got the intensive treatment probably had more resources. They probably had better access to the center. They maybe had additional funds to be able to drive to the center more often. And they were more engaged in their potentially more engaged in their child's well-being than the group that got the treatment as usual. So these groups are not equivalent. Not at all. You don't get to pick what group you want to be in. Everybody wants to be in the clinical trial group, but we need some people who we need some people to get the placebo as well so that we can make sure that the treatment works. And the same's true here. We need some people to function as a control group for a basis of comparison. Now, it's no surprise that when Lovas and his colleagues collected this data, the group that got the intensive treatment showed greater improvement in autistic symptoms. The children showed improvement in autistic symptoms. Well, of course they will. Their parents were more involved and fought for them to be in that group. Their parents parents are probably more engaged and are far more potentially more concerned about them getting better. The treatment as usual group is more likely to have people who are farther out, farther away from the treatment center, and don't necessarily have the resources to help their children as much. And so these groups are fundamentally different from each other. We can't say that the treatment worked because the groups are not equivalent, and that's what a selection effect is. So something that can potentially help with this, in addition to random assignment, which 9 times out of 10 you should always be doing, you should also, if you want to match people, you can do what is called a matched groups design. So if you think that there's a variable that could potentially function as a confound, what you can do is you can match people on the basis of that confound and put one person in one group and one person in the other group. So let's say, for example, we're worried that something like GPA might be an extraneous variable. We take 2 participants that have the highest GPA, we put one in group 1, we put one in group 2. We have the next 2 highest, we put one in group 1, we put one in group 2, and so on, and go all the way around to the lowest. So the idea is that each group should have the same range of GPA variability on the basis of this matching. So if we see a difference between the groups, because we've matched on the basis of GPA, we know that that cannot be a confound. So now let's talk about some different types of experimental designs. So in particular, when we talk about single factor experiments, probably the biggest difference between the two is, are we doing an independent groups design, more commonly referred to as a between subjects design or a between groups design, or are we doing what we call a within groups design or a within subjects design? So here, with the independent groups design, we are going to be looking at differences between groups. With a within groups design, we are making comparisons for a single person across a variety of conditions. So basically, with the within groups design, each person is basically functioning as his or her own control, and we're exposing the participant to all possible experimental conditions and seeing how that behavior changes. So let's start by talking about between subjects designs. So your book talks about a few. So we can do what is called a post-test only design, which is basically what Oppenheimer and Mueller did. So we have our 2 independent groups. Always remember to randomly assign people, even if it's something like a coin flip. Everybody needs an equal chance of being in either group. So flip a coin, put somebody in group 1 or group 2. Ideally, if you have enough people in each group, these extraneous differences should cancel each other out. So both groups should be the same in terms of intelligence levels or grades or working memory abilities and so on. So always randomly assign. So we basically have our 2 groups. We introduce our different conditions. So for example, we get a laptop or longhand notes, and then we get the comprehension test. So that's a post-test only design. We divide people into groups and measure their behavior in response to that independent variable. Hey, I got to keep moving my head. It's like Dr. Gilchrist floating around on your computer screen. We can also do a pre-test, post-test design, and this can be really powerful if you are interested in introducing interventions and you want to make sure that your intervention works. And you want to make sure before you introduce that intervention that your 2 groups are as equivalent to each other on the dependent variable as possible. So again, we're going to randomly assign people. Now, this is based off of research by Mrazek and colleagues. This is a study that is looking at how mindfulness training can potentially affect verbal GRE performance. For those of you who don't know, the GRE is the graduate record exam. It's kind of like an amped up version of the SAT if you want to go to graduate school. The verbal reasoning section is actually pretty intense. So these researchers wanted to see if mindfulness training would help. So they basically randomly assigned people to either a mindfulness class, and we want to have some kind of comparison group. We want to actually give them some intervention, though. We don't want to not give them an intervention because it's possible that the mindfulness group does better, not because of mindfulness, but because they got extra special attention. So we need like a comparison intervention. So Mrazek and colleagues basically put people into a nutrition class. So they're randomly assigned to one of these two conditions. They all take the verbal GRE pretest. Now, here's what's really important. I want you to look at these white bars. So here we've got the white bar so this is pretest for our nutrition group. Here we've got our pretest for our mindfulness group. I want you to pay attention to the fact that those bars are exactly the same height. Like there's no difference between those bar heights. That's important. You want to make sure when you're introducing these interventions that our two groups are equivalent before you introduce that intervention. So that way, if you see a difference in post-test, you'll know it's because the intervention worked and not because the groups were different from each other. Okay, so after we do our pretest, we do our intervention, and then we get our post-test. So I want to first show you the difference between the nutrition and the mindfulness group. There's definitely a difference between the two here, but what's probably more important is the pretest and the post-test within the nutrition group and the mindfulness group. So notice that our nutrition group, their scores didn't really change. Now, notice that this bar is a little bit lower. You might think that that means they did worse, but I want you to pay attention to these error bars. The error bars are overlapping here, and that means if those error bars overlap, they're not different from each other. Now, on the other hand, let's take a look at our mindfulness group. Here, we can see that our error bars do not overlap, and at least in the paper, it's been marked with a star. This shows that this group was performed significantly higher on the post-test relative to the pretest. Now, your book does have a really good kind of helpful way to figure out what's the independent variable and the dependent variable. Typically, your independent variable is going to be on your x-axis. Your dependent variable is usually going to be on your y-axis. Here, it's accuracy on the verbal GRE. And here are our two groups. So this shows evidence that perhaps mindfulness training enhances verbal performance, at least on a test of verbal reasoning. So which design is better? Should you do pretest, post-test, or post-test only? Generally, the situation that you're in is going to determine what design is better. If you're introducing an intervention and you want to make sure that your groups are equivalent before that intervention is introduced, in that case, you probably need to do a pretest. Do we need to do a pretest for something like the note-taking study? Probably not. And in that situation, it might actually be kind of problematic to do a pretest, post-test design. People might figure out what you want to study, and because of that, they'll figure out the true aim of the experiment. In other situations, pretest, post-test designs can make sense, but post-test only designs can still be very powerful and still be very useful to use. Ultimately, it's your call. So now let's talk about Dr. Gilchrist's favorite types of designs within subjects designs. So one of the first things that we can do is what is called a repeated measures design. Now, in this particular case, you are being exposed to multiple conditions at the same time. So here, there's just one group. So we're not dividing people into groups here. This particular study was discussed in your book, looking at whether shared experiences would make you like things more. So they had you either tasting chocolate the same time that a Confederate just happened to be tasting chocolate, and they're the same chocolate, but you're told that it's different so that we don't create any confounds. So you have to rate the chocolate, and then you try it alone while your confederate, that other person, is like looking at a painting or listening to music. So the researchers expose you to all of those possible conditions. You're tasting chocolate with a confederate and you're rating it. Then you're trying the chocolate alone and you're rating it. So you're getting exposed to both conditions, both of these conditions within the context of the same experiment. Now, you could pretty easily turn this into a between subjects design. You could have one group of people tasting chocolate with somebody else and another group tasting it alone. But as we're going to see, within subjects designs have powerful, they're very powerful in a way that between subjects designs are not, and we'll talk about that a little bit more soon. But in the context of this study, the researchers did find that chocolate was enjoyed a lot more when you were sharing the experience with somebody else rather than when you were trying it alone. The other type of design that you can do is something called a concurrent measures design. You're basically exposed to both stimuli or multiple stimuli at once, and you have to make a preference. So here we often look at looking preferences in infants that are not capable of talking. So we present one group of infants with a female face or a male face, so they get both of the stimuli concurrently. That's why we call it this. And then they either are going to look at the female face longer or they're going to look at the male face longer. And by and large, we do find that the majority of infants do spend longer times looking at female faces. But this is another example of a within subjects design. We'll talk more about within subjects designs and why they can be so advantageous and their pitfalls. They're not perfect next time.